Aloha and welcome to section 1.6 in describing pairs of angles. This is our last real heavy vocabulary. There's still a lot of vocabulary interested. This is the last one on describing stuff. This is page 29 to 31 in your journals. Let's get rumbling here. Complementary angles. Two angles which sum to 90 degrees. That's page 48 again. Please look at the diagrams, read the examples in the book. That'll help you out. Supplementary, two angles which sum to 180 degrees. Adjacent angles here have a common endpoint and side. No common interior points. Okay, so if you look at it, angle 1 and 2 up here are adjacent. They have a common endpoint right there. There's their common side. So angles 1 and 2 are adjacent up there. Angles 3 and 4 are not adjacent. They have a common side, they don't have common vertexes. So that makes them non-adjacent, even though they share the side. Okay. And these are all on the next page too. You're going to see these more again. Page 50. Linear pair, two adjacent angles whose non-adjacent sides form opposite rays. That continues over here. Linear pairs are supplementary. That's going to be really important. And recognizing those, we'll look at those more on diagrams here shortly, rather than try to explain it again up here. Vertical angles, this one is really key too. Linear pairs and vertical angles are going to be important for you to recognize. These are going to set up equations, just like the right angles set up equations. Linear pairs set up equations like the right angles. Vertical angles set up equations similar to an angle bisector. Vertical angle, two angles whose sides form opposite rays, or they look like a straight line. So this is our example right down here. This ray and this ray look like a straight line when you put them back to back like that. They have that common endpoint. Very important to recognize in this class. Core concepts. And these are definitely core concepts. These are things you have to get down. We use these extensively throughout the year. I'm doing hand motions as I speak, which you can't see, to emphasize that point. Complementary angles. Two positive angles whose measures have a sum of 90 degrees. Each angle is the complement of the other. So sometimes they'll be adjacent like this and you'll see it visually. Other times they'll be like these two. They won't be adjacent. They can still be complementary. This case you'll have to recognize more often than not. It won't be told to you. The second case over here, you'll usually be told that those angles are complementary and to do something with them. Or you'll ask if they are complementary. You check by adding it up to 90. Supplementary works the same. We measure two positive angles who add up to 180. We've got our visual example right here. Those two angles make a straight line. They add up to 180. These two, just have to catch it. You'll be told it, or you'll be asked to recognize if it's true. Now again, each angle is the complement for the other. So for both of these examples I wrote in down here. For measure of angle A equals 40 degrees. So I have a 40 degree angle. I need to find the complement. Okay, the complement is the angle that adds with 40 to sum up to 90. So I'm thinking x plus 40 equals 90. What angle plus 40 gives me 90? That makes x a complement, because we're trying to add it up to 90. I subtract 40. Let's go back to old red. And I get 50 degrees on that. So the complement is 50 degrees, or the complement of angle A is 50 degrees. Supplement works the same way. This I called the complement x. I'm calling the supplement y. Instead of x plus 40 equals 90, supplement is y plus 40 equals what? See if you can figure it out. Good. Real good. You got 180. You guys must be a genius. Funny how I knew that, isn't it? And then you solve that equation. Minus 40 minus 40. Y equals 140 degrees. So the supplement of angle A is 140 degrees. Adjacent angles, we've already talked about these. You got your common vertex and your common side. Those angles, we can use the angle addition postulate. They can add up to something. In this case, they make a straight angle. They add up to 180 degrees. Okay? And we're going to call that a linear pair, which comes up right down here. So this is a diagram for a linear pair. These are non-adjacent angles. Notice, no common vertex, no common side. It's got to have both to be adjacent. Don't forget that. It's got to have both. Linear pairs, two angles which add up to 180. You're rarely told this. You're expected to recognize it and use the linear pairs to name it and describe it. But those two non-common sides they talk about there, those are the ones that aren't adjacent. Those form opposite rays or a straight line. The common side is this grayed out one. That's actually two sides there that overlap. But those two make a linear pair. Vertical angles are across from each other. 3 and 6 are vertical angles. And I had this in the diagram up here too. Way up here. I kind of showed this up here but ignored it. 3 and 6 are vertical angles. That's those two angles right there. Remember, that's how we mark them congruent. 4 and 5 are vertical angles. Notice those are across from each other. These are across from each other. Notice the 1's congruent to 1, 2's congruent to 2. Sometimes you'll see other books mark them like this. That's my 1. That's my 2. And you can match them up that way. So again, angles 3 and 5 in this diagram, 3 and 4. So the tough part about this diagram is you have vertical angles and linear pairs in it. 3 and 4, those are adjacent, common endpoint side. It's a linear pair. 3 and 6 are vertical angles. Try to get these other ones. Pause this. See if you can get them without my help. Okay, 3 and 5, that's a linear pair. 4 and 5, we said that earlier, those are vertical angles. 5 and 6 are a linear pair. LIN is my abbreviation for linear. 4 and 6 also form a linear pair. And remember, our linear pairs of angles are supplementary. That's not what I wanted. I had that selected better before. That's what we want. Vertical angles are Okay, now for the extra practice. Number one's kind of tough. Use the figure to answer the questions. Name the pair of adjacent, so there's a keyword, adjacent complementary angles. So they have to add up to 90. They have to share a common side and a common vertex. So I need to add up to 90. Nothing in this first diagram there looks like it's adding up to 90. But this second one, I see my right angle there, and I'm going to look at this line right here. Well, if this is a right angle, this also has to be a right angle over there. And it's in this little section over here that we get our complementary angles that are adjacent. Since these two angles, 75 and 15, you can see those add up to 90. It makes sense. If my straight angle is 180 and one angle is 90, the other angle has to be 90. 180 minus 90 is 90. Big idea. We use that a lot in here, actually. So for this one, you're going to have angle TOP. Remember, that could also be angle POT. I think I used TOP in this one. And what other angle? So it was this, which other angle squeezes into there to take a TOP and make it 90? Name a pair of non-adjacent supplementary angles. This is another tougher one. You got to think 105 plus what equals 180? Minus 105 minus 105. And that's the number that you're looking for. It appears twice in this other diagram. So you're going to have LJM. I'll even give you this one, LJM. This is angle LJM. You got to be looking at this angle for that number that you found over there. I will leave that there. Actually, no, that's gone. It's not there. Okay. This one we did before, supplement. Well, supplementary angles add up to 180. C and D are supplementary angles, so they add up to 180. Measure of angle D is 117. So we're thinking here 180 equals measure of angle C plus measure of angle D. You always need to be thinking this. 180 equals measure of angle C plus 117 minus 117 minus 117. I'm going to finish this one. 63 degrees equals measure of angle C. An awesome number because it's the year I was born. We can see our answer over here. On this one, I stopped right here because I want you to think about it. You got two answers with top on it, angle top. You got to figure out which one's right, which one makes more sense. And it should be pretty obvious which is the right one. Let's circle that. Number 5 here. Measure of angle BAC. That's this angle here. It's going to add with this angle here. Oops, that shouldn't just be CAD. Should be measure of angle CAD. And we're almost out of time here. Equals our big angle, and I got to rush through these because we're not going to make it here. That's our big angle, measure angle BAD. Put your numbers in here. This is 90 degrees. We get it from the right angle. Put your other numbers in there and solve it. Identify your pairs down here. You're just going to have to try that one on your own. I'm pretty much out of time here, so I'm just going to say aloha. I don't have either of these circled to do. Good luck.